Hello friends, welcome again in mechanical engineering RS Khurmi Thermodynamics. We have completed up to question number 25 and we will be continuing from 20 number 26 question 26. Okay, so let's begin. When two bodies in thermal equilibrium with a third body, they are also in thermal equilibrium with each other. So basically this question is the statement of one of the three laws of thermodynamics. You might have guessed already, and the correct answer is A, zeroth law of thermodynamics. Okay, so let's move toward the second question, that is question number 27. Before talking to question number 27, we will be discussing some laws. What are the three laws of thermodynamics? So our basically today's session will be on three laws: zeroth law, first law, and second law. Okay, so the first one is zeroth law of thermodynamics. It is the law which says that when two bodies are in thermal equilibrium with the third body, okay, if two bodies A and B is in thermal equilibrium with the third body C, and they are also in thermal equilibrium with each other, okay, means the two bodies is also in thermal equilibrium with each other, then it is said that all the bodies has the same temperature. It is explained by zeroth law of thermodynamics. In the similar way, first law of thermodynamics states that heat is convertible into work. Okay, heat is convertible into work. It also says that we cannot say that energy is wasted. It changes from one form to another form. Basically, it also talks about the conservation of energy, which is illustrated in question number 27. That option D is the correct answer. Question number 27 says that first law of thermodynamics deals with conservation of energy. Is the correct answer. Okay. Similarly, if we talk about second law of thermodynamics, it states that without any loss or without external work, we cannot have energy converted into one form to another form. Means we cannot have the engine with 100% efficiency. It means we have some loss. Okay, if we have to make water reach from lower level to higher level, it needs some external source such as motor. Okay, so there needs to be external agency to have converted our heat into work. Okay, we'll be explaining more on the next question, so let's move towards the next question. Next question is question number 27. It says that according to first law of thermodynamics, total energy, okay, total internal energy of the system during the process remains constant. Total energy of the system remains constant. Work done by the system is equal to the heat transfer by the system. And the last option is internal energy, enthalpy and entropy during the process is constant. So which one is the first law of thermodynamics? Okay, so the option is B. We have already discussed that according to first law of thermodynamics, total energy in the system remains constant. Okay, so the question number 22 says that total energy remains constant. Let's move toward question number 29. It says that energy can neither be created nor destroyed, but it can transfer from one form to another form. Yeah, it is obviously first law of thermodynamics. We have already discussed this. Okay, let's move toward the question number 30. Kelvin Planck deals with. Kelvin Planck is the statement given under under second law of thermodynamics. Kelvin Planck and Clausius are the two statements which are being discussed under second law of thermodynamics. I will give you a trick to just remember those statements under these two headings. Let's first talk about the Kelvin Planck. Kelvin Planck states about conversion of heat into work. You can, if you observe work, and the last letter is K, and the first letter of Kelvin Planck is also K. So from this K and K you can relate the idea that Kelvin Planck deals with conversion of heat into work. And similarly, if you talk about Clausius, C for Clausius and C for cold. Okay, so under Clausius statement you have to remember that, okay, remember about the cold and the hot body. We will be discussing further in next question. So let's move towards the next question. The next question is 31. Heat and work are mutually convertible. This statement is called heat and work are mutually convertible. Yeah, it is stated by the first law of thermodynamics. So the 31 has answer B. Okay, so let's move toward the 32. The measurement of thermodynamic property known as temperature is best done. The measurement of thermodynamic property known as temperature is best done. So this question is about the temperature and the measurement. Okay, measurement of thermal property or measurement of temperature is based upon zeroth law of thermodynamics, because under this heading we have just discussed that if two bodies are in thermal equilibrium with the third body and another two bodies are also in thermal equilibrium, then all the bodies are said to be in thermal equilibrium. So the subject of temperature is always discussed under the zeroth law of thermodynamics. So the correct answer is zeroth law of thermodynamics, option A. Okay, let's move to the question number 33. The machine which violates the first law of thermodynamics is known as perpetual machine of second kind. Yeah. So before discussing on this, we have to just know about perpetual machine of first kind and second kind. First of all, I would like to say that the perpetual motion machine is just an ideal machine. It is a machine of dream. You have never those type of machines. So this is the only a hypothetical condition. Okay. So the perpetual machine of first kind states that energy is not required. Okay, energy is not required to just make a machine to work. It says that we don't need any energy. Okay, but it is ideal condition. It can never be the such situation where we don't need any energy to operate a machine. So first kind is about this, and second kind is that second kind is talking about that energy is always converted 100% without any loss to operate a machine, which is also a hypothetical condition. There can never be such a situation about that where every input is converted into output, meaning it has 100% efficiency. So the both statement is ideal statement, and these are the statement of the perpetual motion machine of first kind and second kind. Now let's talk about the question number 33. The machine which violates first law of thermodynamics is known as perpetual machine of second kind. No, it is incorrect. It is B is the correct answer. Okay, so let's move toward the question number 34. The perpetual motion machine of the first kind is possible, impossible according to the first law of thermodynamics. It is impossible. Yeah, we have already discussed that these machines are impossible to bring in the real world. Okay, so 32 has impossible. Option B is the correct answer. Now 33. Okay, 33 we have discussed 33, 34 and 35. According to the Kelvin Planck statement, the perpetual machine of is impossible. Kelvin Planck talks about heat into work, okay, and the second law, second kind of perpetual motion machine is also talking about every heat is converted, or every input is converted into output. So it is second kind, okay. So the option B is the correct answer. So let's move question number 35. According to Kelvin Planck statement, perpetual machine, okay, yeah, we have done it. Question number 36, which of the following is correct according to Clausius? We have already discussed that Clausius talks about the cold body to heat body, अथवा lower temperature to higher temperature. Without if you see the options, option B, it is impossible to transfer heat from a body at lower temperature to higher temperature without any aid of external work. If you don't add any external work, we cannot transfer heat from the cold body to hot body or lower temperature to higher temperature, okay. So the correct answer is B, and you have to make a trick to connect this Clausius with the C and C. Cold Clausius for C and cold for C. So C and C, you have to just for remember, it is not a principle, and you have to make a trick, okay. Let's move to other question number 37. According to Kelvin Planck statement of second law of thermodynamics, so if you talk about the Kelvin Planck, it talks always do conversion of heat into work, okay. So option A, it is impossible to construct an engine working in cyclic process whose sole process is to convert heat into work. Yeah, it is the correct answer. We cannot construct an engine in a cyclic process whose purpose is to convert total heat into work, okay. So it is impossible, and it is stated by Kelvin Planck statement. Let's move to our question number 38. Which of the following is correct statement for second law of thermodynamics? So let's see the answers. First answer is, it is impossible to construct an engine working in a cyclic process whose sole process to convert heat into work. Yeah, it is Kelvin Planck. It is correct. Similarly, option B is also talking about lower temperature to higher temperature transfer of heat. Yeah, it is also correct. And option C, it is talking about there is a definite amount of mechanical energy which can be obtained from a given quantity of heat. Yeah, it is also correct. So all the options are correct. So all will be the answer. Now let's move to our 39. The heat flows from the cold body to the hot body with the aid of external work. Yeah, it is correct, and it is given by Clausius. Yeah, we have already discussed. Second law of thermodynamics defines. Yeah, it is very important question, and it has been asked different times in the competitive exams. Yeah, it is impossible. Sorry, second law of thermodynamics defines entropy. D is the correct answer. Okay, because entropy is wastage, entropy is randomness. Yeah, and second law of thermodynamics also states that there is some wastage, okay, there is some wastage or external work, so it is somehow related with entropy. Second law of thermodynamics is associated with entropy, okay. Question number 41. It is impossible to transfer heat from a body at lower temperature to higher temperature without the aid of external source. Yeah, it is correct. So question number 42. It is impossible to construct engine in a cyclic process whose sole process is to convert heat into react. Yeah, it is impossible. It is the statement of Kelvin Planck, okay. 43. In the first law of thermodynamics, the total energy of the system remains constant. Yeah, we have already studied it. It is true. And 44. The state of substance whose evaporation from liquid is complete, it is known as. Yeah, it's a very important question. If the liquid is converted totally into evaporated, okay, so that is called perfect gas. You have to remember this, okay, perfect gas. If it is not converted, so suppose question 45 says that the state of substance whose evaporation of the liquid is partial. Yeah, it is partial. It is not the total liquid has been evaporated. Some liquid is there, so this is known as steam. No, this is not as steam. Steam is that it is. Okay, so the correct answer is disagree. It is not. 45 means B. Okay. 46. The behavior of superheated vapor is similar to superheated vapor is similar to perfect gas. It means it behaves same as perfect gas. Okay. So let's see question number 47. The behavior variables which controls physical property of perfect gas is the variables which controls physical property of perfect gas is pressure exerted by the gas, volume is occupied by the gas, temperature of the gas, and all. So the option D is the correct answer, because all gas has different dimensions, so we can define it. So the pressure, volume, temperature are all the parameters which need to be considered before considering the property of a gas. Okay, so let's move towards the question number 48. The behavior of perfect gas undergoing any change in the variables which controls physical properties is governed by. Okay, it is governed by all. Boyle's law, Charles law, Gay-Lussac's law. Okay, it is governed by all. So all is the answer. 49. The absolute pressure of the given mass of the perfect gas varies inversely as its volume when the temperature remains constant. This statement is called Boyle's law. Yeah, absolute pressure of the given mass of a perfect gas varies with the volume. Pressure varies with volume. Having temperature remains constant, then it is obviously Boyle's law. Boyle's law has at constant temperature pressure is directly proportional. Pressure is inversely proportional to the volume. So PV constant is simply a Boyle's law. Okay. So let's move toward the Charles law. Charles law states the perfect volume of a gas is directly proportional to volume at constant pressure, means V by T is constant under Charles law. So the here is volume is directly proportional to temperature. So the option A is the correct option. Okay, I think the video has gone long and you might have feel somehow easy. Okay, you can comment in this video for any improvement, anything that I can do from my side for your improvement, for your better understanding, and I will be there for every help, everything for your preparation of mechanical engineering. So do comment, do like, and do share with this video. Thank you very much for this consideration. Okay, thank you.